Okay, so we finished our factoring project, and now we're going to do the second half of the notes. So the notes, I think, are a little long-winded, and we'll go through it rather quickly. So what we're going to do first is we're going to look at where we're headed. What we want to have happen is we want to have something that looks like a binomial times a binomial, sort of like when we're doing our factor by grouping. So let's analyze this and look at it a little bit more closely and see if we can notice any patterns. When I double distribute number one, what you notice, I hope, is that it creates a 4-term polynomial. And we usually add the two middle numbers together and we get a trinomial as our final answer. But what if we didn't do that? What if we instead went backwards and we looked at this a little bit more closely and we said, oh wait, what is the GCF for that part, that group? And what's the GCF of that? You'll notice that it is x times x minus 5, and this is 2 times x minus 5. You should end up back where you started. So that's the idea. So look at the second one. If we have this multiplied out, it's just 3x squared plus 6x plus 1x plus 2. Again, if we do the factor by grouping, 3x times x plus 2, this is 1 times x plus 2, it ends up back where we started. So the question becomes, how do we end up getting the right numbers in the middle? We need to have this split up the right way so we can use factor by grouping to create this. And I know I skipped a little bit of notes, but let's scroll down to this part where it says factoring trinomials by the x and grouping method. This is the goal today. We want to factor by grouping, and we're going to use that trick with the x factor to figure it out. So on this example on the right side here, first thing we're going to do is we're going to make sure it's in standard form. So we're going to make this 2x squared minus 3x minus 14. Now most of the problems are going to be already in standard form, but you should always make sure. Can we GCF on this problem? No, you can't GCF on this. So let's go on to step 3. Identify A, B, and C. Well, A is 2, negative 3 is B, and negative 14 is C. What we're going to do is we're going to create our little puzzle by multiplying the first and last numbers, and that's going to be our top numbers. That's negative 28. That's how we set this up. The bottom number is going to be our negative 3. So you need to come up with two numbers that multiply to get negative 28 and add up to negative 3. So I'll give you about 10 seconds to think of some numbers. Okay, you should have it. It's been 10 seconds. This is negative 7 and a positive 4. So now let's take it to the next step. What you just figured out with those two numbers is not only two numbers that multiply to get negative 28 and add up to negative 3, you actually split the middle. This middle term is going to turn this into 2x squared minus 7x plus 4x minus 14. These add up to negative 3. You just got to pick the right numbers. So rather than randomly picking the numbers, we want to pick two numbers that are going to work for us. So now, split the middle, which is what we did. We're going to factor by grouping. See if you can factor by grouping and factor this to the end. What I'm asking you to do, if you're still staring at this screen, is I'm asking you to factor by grouping. So for example, the first part you take out an x. Finish this problem, please. So you can take out a 2, 2x minus 7. So they both have a 2x minus 7 in common. X plus 2 is the leftovers. This is the fully factored answer. Now here's the best part. This number 9, you don't have to necessarily do this every single time, but if you're unsure if you did a good job, you could always multiply your answer back together using the double distribution method. So 2x squared plus 4x minus 7x minus 14, or 2x squared minus 3x minus 14. Check it back with the original problem, and if it's different, you did something wrong. In this case, that is the original problem. We're in good shape. So let's go ahead and do the same thing for this next problem right down here where it says example. So this could be a little bit of an organizational nightmare. So here's my personal advice. The X factor part, put that off to the side, either the left or the right. Remember, we're going to take the top as a times c. So we're going to take the 1 in front of the x squared times -6, and the bottom is going to be the 5. So it's going to be -6 on the top, 5 on the bottom, two numbers that multiply to get -6 but add up to +5. I'll give you 10 seconds. Okay, 6 and -1 are the two numbers. So then you're going to split the middle, rewrite this problem as +6x minus 1x minus 6. Then you're going to factor by grouping to finish the problem. If you do this correctly, you will get the final answer of x minus 1 times x plus 6. I think somebody yesterday said, can you have those backwards and have x plus 6 first? The answer was yes, but you should have those as your two binomials that are getting multiplied. All right, let's scroll on to the next page. So as you can see here, there's a whole bunch of examples that we can do this. So here's what I want you to do. I don't want you to go crazy. Let's start easy. Let's start with one example. Do number 1. See if you can split the middle, and then group factor by grouping to get a final factored answer. Pause the video and give yourself about a minute. Okay, so to figure out the top number, it's the first number times the last number, the bottom number is 5, which is the middle. If you split it, you should end up with x squared plus 2x plus 3x plus 6. And if you factor by grouping, you should have x plus 3 times x plus 2. Okay, so now I want you to try to do number 2 and number 3. Pause it for about a minute, and then we'll see what the answers are. Okay, so time's up. Let's look at the answers. Both of these were tricky in their own ways. For example, number 2, did you GCF? If you didn't, you did not fully factor the problem. And then the other part is, when you did the whole X factor trick, did you do that with only the part in the middle? Sorry, only the trinomial after you GCF. That would have been the best way to go. The numbers probably were huge if you didn't GCF first. So your final answer should be down here, 2x cubed times x plus 4 times x minus 6. Now the other one was difficult because it had x to the 4th and x squared. So when you split the middle, you got to think about it a little bit. It's not going to be 3x and 5x. It's going to be 3x squared and 5x squared. So if you didn't do that, it's possible you have the wrong answer. So your final answer should be x squared plus 5 times x squared plus 3. So look these two problems over. Talk at your tables. Talk with the sub if necessary. Try and make sure you understand how to do this before we go on to the next set. All right, so there's 3 examples left. Here's what I want you to do. I'm going to give you 2 minutes, so you're going to pause the video after I'm done talking. For two minutes, you can try and get these 3 problems done with your group. As a group, you want to try and get all of these correct. See if you can get 3 out of 3 by factor by grouping after you split the middle. Don't forget to GCF first. Go ahead, pause the video and see if you can get these right. Alright, so hopefully you've had enough time to look this over. So number 4 and number 6 were pretty straightforward. So go ahead and check those answers. But the middle one, and it's a little hard to read here, it's -1x times x plus 2 times 3x plus 2. Now if you're wondering where the -1x come from, you had to GCF first. After you GCF, with what is left inside the trinomial, you're going to factor that part alone using the x factor and the factor by grouping. If you do that correctly, that should be the answer you get. So that's it for the notes, guys. So go ahead and work on the homework. It's quite possible if you work together and you actually are productive, some of you know who I'm talking to, you should be able to have no homework tonight, and you can go on and we'll do something else tomorrow. So hopefully that's good. These videos will be available on Schoology as well if you want to look them over again. Otherwise, I will see you on Friday.